Good afternoon, everyone, and thank you for joining us for what is officially our last talk of the two-week series of talks that we've had at the Low Carbon Design Institute summer residency of 2022. I'm extremely pleased to welcome again Ross Atkin to the program, and really finishing with a really full-on design talk. As you know, we also have explored different aspects of design, but this is the most design talk I think we have in the program. Ross is a product designer based in London. As a consultant, he works mainly on physical infrastructure and electronic devices, and has a strong interest in accessibility. He also makes and sells reusable cardboard robot kits under the Crafty Robot brand, which I will then also put a link to in the chat for our residents. His talk is extremely generously sponsored by Ben Tarrant, who I suspect, Ross, you know. And so I will hand over to you now. Thank you for coming.
Amazing. Thank you so much for having me back. I was worried that maybe the talk had been a bit critical, but so it's really cool to be back, and amazing to be the last one, I guess. Yeah, this is this is it's kind of biographical, this talk. I guess I talk about a lot of my different things I've designed through my career, but it's also really polemical, because ultimately, I guess it's about where I think the limits of what designers can do to address climate change, and what I think we should be doing, I suppose. Yeah, thank you for your attention. Let's see if I can share the presentation.
Oh, he's gone. And you're back. You're muted though. Let me ask you to unmute, maybe that works.
Oh, that was weird. It seemed to mute me when I let's see if that fixes it. That right? Alex?
Yeah, that works.
Cool. Okay, great. Sorry about that. Yeah, so as Alex said, I'm a designer engineer based in London, and we're going to start, I guess, at the beginning. And so I grew up, when I was at school, I had a New Scientist subscription, and this was kind of in the end of the 90s, and so I was kind of, if you read the New Scientist then, you were very worried about climate change and you thought it was very important, but it felt like people that didn't read the New Scientist didn't think that yet. But I started my career designing street furniture, and I was really, really keen to try and do sustainable design as much as possible. And one of the first projects I worked on was to design this bench, and it needed to comply with a load of standards that TfL had set for street furniture to be put on major roads in London. But I was very, very keen to try and make this bench as sustainable as possible. And it's made of two things, basically. So this bench is about as simple a product as you can get, really, in terms of product design. It's got slats and it's got standards. And the standards are made of cast iron, which I thought, and I still think, is a fairly sustainable material, because it's really, really, really easy to recycle. It's been widely recycled for hundreds of years. And most of the cast iron that you get is mainly made of old cast iron. But then the slats were more complicated, because basically had these kind of 4 choices of things that we could use to make these slats. We could do it with slats that were made entirely of post-consumer recycled plastic that were coming from Belgium, and they were kind of heavy and not that strong. Or we could use slats that were made out of industrial waste with steel reinforcement in it. Industrial waste plastic with steel reinforcements. They were stronger, and because of that, we needed kind of, there's like a, in this picture you can just about see, there's like a steel strap under the bench, that because we ended up using the Belgian slats, we needed that steel strap to make the bench strong enough. So if we'd used the steel reinforced ones, we wouldn't have needed to do that, and we'd probably have used less steel in the bench. But they came from China, or we could have used FSC certified Iroko from Indonesia, or we could have used FSC certified oak from a farm in Germany. And we were assembling the bench in Gillingham in Kent. And I was trying, pretty hard to work out what was the most sustainable material to use. And all I could really find in terms of guidance were like rules of thumb, use recycled materials, for example, use sustainably sourced wood, don't use plastic. None of those rules of thumb actually helped me from these choices. They could all meet some of those rules of thumb, which was actually the best one. And then part of the other equation with this was that we were trying to sell this bench to TfL. And so we were sort of trying to meet this green procurement code that was in force in London at the time, which was written by this organization called London Remade, which was this kind of social enterprise that was trying to do circular economy stuff in London, I guess, last time this was cool. Their kind of actual code was just a series of tick boxes, basically rules of thumb about whether you'd kind of met that rule of thumb or not. And I was kind of, I guess, quite suspicious of this, because I felt like I could have, kind of populated their tick boxes for any of those options there and sort of won, I guess. But it didn't help me to tell which one was the best one, the one that would emit the least carbon. And then also the other thing I realized was when I was trying to sort of look at it and trying to work it out, that actually the emissions associated with moving the parts of the bench around were very, very significant. And they were very, very heavily impacted by like how big the batch was. So if we were making a big batch, we would definitely be emitting a hell of a lot less emissions per bench than if we were making a small batch. But then also, where we were assembling it also had a big impact. So if we could assemble it closer to site. So there was a whole load of emissions associated with like choices we were making in how we were structuring the supply chain of it that weren't even to do with design or material choices, but that still would very, very heavily impact the emissions associated with making this product. So I kind of, we guessed, we used the one from Belgium. We made some benches. I didn't feel satisfied by the whole process, as you can tell, I suppose. So after that, I went to do my master's at the Royal College of Art, and I guess one of the things I was still, very, very interested in, how do we design to reduce carbon emissions, and on my group project, finally a group project, I worked with some other people that were, and we ended up making a kind of design for intervention, a kind of tariffs and interfaces for electricity to kind of utilize some of the benefits of having smart meters. But during the kind of initial research phase of the project, we did some sort of scenario planning. And I still think about these scenarios quite a lot, even though we did them in 2008. And the scenario planning, when you do scenario planning, you basically try and map out the sort of critical uncertainties to do with how the future is going to pan out, or at least the aspects of the future that you're really interested in. And then you sort of plot different outcomes for those critical uncertainties against each other, and then you have scenarios fall out of that. So we were really interested in, if you do kind of some very, very rough resource budgeting, or at least you did it in 2008, you found that for us to to avoid kind of catastrophic climate breakdown, then everyone in the world needed to be consuming roughly 10% of the resource budget that people in Western Europe were consuming then. And so we were kind of looking at the critical uncertainties involved in getting there, and they're mainly how much solves certain problems. To what extent do governments get involved and coordinate action to kind of to actually pull down emissions, and to what extent do people's values change and we sort of move away from consumptive lifestyles, and possibly away from consumerism. And it's so we sort of, out of that fell these like 4 different scenarios. It was basically we called them techno-fix, value shift, crash, and global governance. And basically the techno-fix future is the future where we've developed loads and loads and loads of technology that, like full circularity for manufactured goods, full circular resource use, fusion power, really widespread renewables, hydrogen for fuel and stuff. And then effectively consumerism goes on unabated because we've managed to make that sustainable, at least from the perspective of climate change. The value shift scenario is where basically we just use a lot less stuff, and we sort of preserve high technology and high embodied carbon goods and facilities only for the things that make the biggest impact on our quality of life, like healthcare. And otherwise, we're living a lot more like, well, in the picture, another part of the research was we went and lived with some kind of hippies that were living off grid in Wales for a while. And so yeah, I guess a lot of the stuff I drew in that picture was kind of based on things we'd observed the way they lived. And then the sort of global governance scenario was where basically you've got governments working together and really coordinating action, and potentially things like kind of carbon rations, and a much more the government is much more kind of interventionist in pulling down emissions. And then there's the crash scenario where we don't do anything, and there is kind of catastrophic climate breakdown, and then most people end up living on very, very constrained resource budgets because there just aren't the resources anymore at all. So 2 things to say about them. I guess firstly, when thinking about things that live in the future and things you're trying to work on, I think it's useful to have scenarios like this, because if something works in several of those scenarios, it's probably more likely to be something that we're probably, or very likely to need in the future. Whereas if it's something that only works in one of the scenarios, then it's still something we might need, but there's a good chance it isn't something we're going to need. So I guess that's a reason to do this kind of activity as designers. The other thing is, it's really interesting reflecting on these now, having put them together in 2008, because we're kind of, in different ways, we're closer to different ones, I suppose. So I think relative to what we thought in 2008, technology has moved a lot faster. The cost of renewables has gone down a lot. Like electric vehicles have come on much faster than I think we thought they were going to. And so in that way, we've moved a bit towards techno-fix. I think values have shifted a bit as well, and not that much. And again, it's interesting where they have shifted, not necessarily in the most productive ways, which I guess I'll come on to afterwards. But I feel like the shift towards veganism, I guess, is definitely an example of a value shift that is making a significant impact on carbon emissions, or will do if it continues. And then I also think we're kind of moving a bit towards governance as well. In 2008, whatever, we were about to go into Copenhagen, or we just had Copenhagen, and that was a bit of a disaster, right? And it looked like international action on climate change was getting much further away. But obviously that sort of turned around a bit in Paris. And it's also interesting to see the the action that's gone on around harmonizing corporation tax across countries, because for me, that's exactly the kind of example of tackling a problem at a global level like this. Obviously, it's not actually tackling climate change, but the fact that it's happened, it is indicative that this stuff can possibly happen. And I think that's quite encouraging. We're also moving faster towards crash than we thought we were going to, because obviously glaciers are retreating faster. We seem to be entering into feedback loops that are very worrying. So yeah, it's definitely a mixed picture, but I feel like I feel like I have used these scenarios a lot in thinking about things that we could make, I guess. And so I found them useful. Coming out of those and trying to think about designs that probably make sense in multiple of those scenarios, I made up these rules of thumb, basically based on my understanding of looking at resource footprints for different things. And these are my rules of thumb for trying to design things that I think have lower embodied carbon and will lead to reductions in carbon emissions relative to kind of business as usual design, I suppose. And the first one is try not to make anything. Like, if you can avoid making a physical product, do, because physical products have much higher resource footprints than non-physical products primarily, except for cryptocurrencies, I guess. Don't downcycle materials. I assume you understand what that means, but just in case, like, don't use the material in a way that means that it can't be recycled, or if it can be recycled, it can only be recycled into a much lower value product than the product that you've used it in. Use materials that themselves have low resource footprints. Make things that remain useful so that people hang on to them for a long time, and then hopefully don't buy new things. And then try and make things that actually prevent resource use, particularly energy. Something I used to be obsessed with for a few years was like shopping carts that like old people sometimes use to go to the shops. I thought that this was like a really important product to try and work on as a lever, because it was the kind of product that would stop someone using a car to go to the shops. And then if you stop them using a car to go to the shops, you might stop them having a car. And then the emissions that you'd be mitigating by creating that product were much, much, much bigger than the emissions associated with making the product itself. And I think those are kind of really good opportunities for doing low carbon design. But the problem with rules of thumb is, these are sort of based on, as I said, these are based on looking quite a lot at resource footprint for different things and thinking about it. And you get a great opportunity to do that when you're doing a master's. But fundamentally, they're rules of thumb. And I guess I think it's worth flagging this issue that we designers love making assumptions. And I've got this kind of illustration of that, if you don't believe me, I guess, which is this quote from this blogger called Jess Tom, who blogs at touretteshero.com. And so she's a disabled woman blogging about the experience of being a disabled woman, I suppose. And she wrote this blog post, which is really worth reading, about disability dongles. And what she means by disability dongle is basically anything that's been designed, like a big kind of shiny, exciting looking bit of design that designers get excited about and potentially she sees in the press, but actually doesn't solve a problem for disabled people. And so she says, rather than feeling excited by the aesthetics, ingenuity and potential of new products, and left feeling dejected by designs that seem to be based more on assumptions about disability than on lived experience. These impractical designs are celebrated and impressed on social media and end up winning awards. Seeing this happen over and over again is particularly frustrating because I know firsthand how powerful design can be. So basically, disabled people have this impression that designers, most design that they see that's called design, that's for disabled people, is designers making assumptions about them without checking with disabled people that those assumptions are true, and consequently designing things that aren't actually useful for disabled people. And disabled people are right there. Like, that, if you want to go and talk to disabled people about something you're designing, it's relatively straightforward to do that, and then not have to design based on assumptions. And I do a lot of work on accessibility, so I do that a lot. But it's completely possible and straightforward to design based on the actual lived experience of disabled people. And yet, seemingly a majority of designers that are seeking to do that don't do that. They're just happy to make assumptions about what they think disabled people want and need, and then design based on them. And if that happens with disabled people who are right there, and actually who can write blogs to call out, like, when that happens, how do you think the earth feels, right? Like, it hasn't got a voice. It can't say, actually, this is totally not what I needed. This is not actually reducing carbon emissions. This is making things worse, potentially. The earth can't do that, right? It doesn't have a voice. And in a way, the only way that we can give the earth a voice in this is to actually quantify the emissions associated with design choices we're making, which I'll come on to. But thinking about, I guess, my rules of thumb, I was looking through this 5 design modeling circular economy article from The Guardian. And it's kind of 3 of the 5 are basically taking stuff and bonding it in thermosetting resins, which themselves have very high embodied emissions. Definitely is downcycling, because once you bound something in a resin like that, there's no way of recycling it. They've even made it much harder to incinerate the thing to get energy back off of it, because they've made it really, really hard to grind up, probably, and they've also probably bound. So because it's hard to grind up, it means when it does burn, it's much more likely to burn incompletely and generate unpleasant toxic emissions. And it's also the resins themselves are also likely to, even if they were perfectly combusted, much more likely to generate toxic emissions than the actual things that they've bound into these resins. So to me, it's like these people all think they're doing, and that, and The Guardian thinks they're doing sustainable design and they're modeling the circular economy, but you don't have to think about it very much to see that they're really not. But as I guess, as I was alluding to before, in a way, we shouldn't even be talking about rules of thumb at all. I can say I think my rules of thumb are better than the rules of thumb they were using, but fundamentally, we need to be talking about resource budgets, and we need to be talking quantitatively about carbon emissions associated with different design choices. Otherwise, we have no idea whether we're actually helping or not. So I wanted to introduce you to life cycle analysis, or life cycle assessment, which is a technique for assessing the environmental aspects of the digital impacts associated with products by compiling inventory relevant inputs and outputs of product system, evaluating potential environmental impacts associated with those inputs, interpreting the results of the inventory analysis and impact assessment and phase in the objective of the study. Basically, actually trying to sit down and work it out using maths, and to say, right, what is this thing that I'm proposing that we make and people use, and what's our baseline of what they would do if they didn't do that, and which is better, which emits less carbon, because that's what we're trying to do, right? This has been around for quite a while. There are, you can read about how to do it, but it basically gather the data and then weigh everything and then try and work it out. There's in some places it's used quite widely. I guess it's used in the construction industry quite a lot, and in a way, construction projects lend themselves quite well to it, because the inputs are relatively simple and there aren't that many of them, and you know the weight of everything, and it's mainly, you've got massive weights of everything, and actually the because of that, the kind of you're not most of the time you're not moving things that far actually. So the actual embodied carbon per kilogram of the materials you're working with gets you quite a long way to the actual carbon footprint of the thing that you're making. And I've got a former client of mine, Marshall's. They have this really nice carbon calculator on their website that kind of, if you want to pave a street or a patio or something, you can put in which paving products you're thinking about using, how many square meters, and they'll tell you exactly how many kilograms of CO2 associated with doing that, at least the paving itself. And you can compare different options and try and work out the lowest carbon option that you've got. And I guess I'd like to see a lot more of this where it is possible and where materials are simple. The thing is, even when it is simple and we have relatively good data, we still don't seem to actually use LCAs to make design decisions in the built environment. So these are two of the venues for the London Olympics, which was apparently the most sustainable Olympics ever. And they've basically got equivalent, they both got roofs, and the roofs have a more or less equivalent span that's unsupported. So they both got roofs that have steel in them and have an unsupported span that's about the same. And one was deemed excellent by the building research establishment that certifies buildings as sustainable, and one was certified very good. The one that's excellent uses 100 tons of steel to hold the roof. That is an equivalent span up. So emitting about 185 tons of CO2 in doing that. And the one that's very good used 2,800 tons of steel to hold the roof up and emitted 5,180 tons of CO2 roughly to make that steel. So like, to me, it seems totally insane that you could have Olympics that were the most sustainable Olympics ever and build a building that was, functionally basically the same as another building you were also building on the same site that used 28 times as much steel and basically, emitted 28 times as much CO2 as a result of using that steel. And then they still it's still a very good sustainable building apparently. Yeah, it's sort of mind-boggling how even when we have the data, it doesn't seem to be used. But when we're actually trying to use this stuff for the kind of smaller products that we're often designing as product designers, things get more complicated still, I suppose, and there are more limitations to doing LCAs. So I wanted to tell you about the first robot kit I made, which was really, really, really simple. I wanted to make something that allowed kids to make toys that moved really easily and where you didn't need batteries. And so I wanted to make a bit of electronics that could make something move and be reused over and over again, and to make lots of different toys. And then originally I just designed a little bit of electronics, which is that thing down there. It's called a Fizzbit, and it's got a supercapacitor, which is what they use in kinetic engineering recovery systems in Formula One cars. And it's got a little tiny motor with an eccentric weight that, when it spins, makes vibrations. A bit like in your Nokia phone, if you're old enough to have had one of them, that made it vibrate before Apple invented the clever taptic thing. And it charges from a USB, because obviously I didn't want people to need to buy a charger. So I wanted to make sure that you could charge it with the charger you already had. And I thought everyone has the USB output on something, so they can charge it with that. And originally I licensed it to a company that makes kind of electronic kits for schools, and they were making and selling in schools. But I sort of realized it wasn't a very good present for anyone, just getting the circuit board. Even though the idea was you could use it to make whatever you wanted, it needed something that came with it that you could make straight away. So I made these little cardboard robots that you fold up to and stick it in, and then they run around. So you can see it working up here. And then yeah, there's kind of a picture of a lot of different things we made with them, including biscuits. And then also the idea was, in order to keep it kind of fresh, so you didn't need to buy a new thing that had lots of the actual Fizzbit, but you can have a new toy often. We put lots and lots of designs on the website of different things that you could print out and cut from a low resource footprint thing, which is paper or heavy or thin card, cut out, fold, and then have a new toy, but you're reusing the bit that's got the high embodied resources. And then, yeah, as you can see, all the rules of thumb: no plastic, no batteries, no reusable, recyclable. So I thought, before we did the LCA, I thought, we're smashing out the park with this product. It's like, that, you know, there couldn't be a more like sustainable toy than this, relative to things you have to put batteries in. You know, you can't regenerate like this and stuff. But then I did the LCA, and I found that that wasn't really the case. Which are these tiny silicon and polypropylene kind of insect things that they take a few of these little coin cell batteries that are shown in that picture, and they also vibrate and run around in much the same way that my little cardboard robots do. And actually, you know, so here we did find that if you made like 5 cardboard robots and you used 2 Fizzbits between them, that was indeed, you know, whatever, about a third of the CO2 emissions relative to playing with 5 hexabugs and playing with them for 10 minutes, with 2 of them for 10 minutes at a time each day for a year. So yes, better, but only better if you assume quite a lot of use, I guess. You know, 2 toys, 10 minutes a day each, every day for a year. To me, that's probably, if I think about what I think, the amount I think people probably use these, I think that's quite optimistic, I guess. And actually, if you reduce the amount they're used, then the relative difference between the batteries and not having the batteries becomes a lot more marginal. And the reason that actually our robots, you know, kind of weren't that great, I guess, was because in order to make it all work and not use any plastic, we ended up making the circuit board a bit bigger than it needed to be. And actually, the material that they make circuit boards out of, FR4, has a really high embodied carbon per kilogram. And so because of that decision, we actually made it, so we would have been much better, it would have been a lower carbon toy if we'd made a plastic casing for it and made the circuit board smaller, which, you know, you'd only work out by doing the life cycle analysis. And we think plastic is bad, and our rules of thumb say we shouldn't be using it. So I think it's always, well, I learned from that it's always really important to check. So a few years later, partly because people were like, started to say, so you're making, you know, you're doing robotics. And I was like, ha, 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 we're not doing robotics. But with these little things, they're definitely not robots. But then we thought, well, what if we were to make an actual robot, programmable robot that worked with an app and everything, that had the same carbon, really, really, really useful.
Ross, we can't hear you anymore. Ross, I think we've lost you. Unless I'm not the only one. I hope I'm not the only one who's lost Ross.
No, I lost him too. I thought it was because my internet is so bad. But
No. No, we've lost him. Oh, here. Okay, he's gone, but I'm sure he'll join in a second. I'm going to send my files to everyone next year.
Yeah, good idea. No, but I think it's something to do.
Oh, here we go. He's back.
Oh.
Hi, Ross. Sorry. If you want to pick back up at the Smarty Bots, I think we lost you for a good 30 seconds. So you're unlikely to, yeah.
And you're muted.
And you're muted.
Am I showing the right thing? Can you see them again?
Yes.
Cool. Okay. Sorry about this. yeah, you get in the box, you get cardboard to make a kind of a robot that you can put your phone on and run an AI in the phone. And again, I think that was a useful whatever. I think that made we made a robot that you could, had AI and you could learn a bit about kind of seeing AI behaving in the world. But it meant we could make it much cheaper than actually putting a processor and a camera that could deal with that in the robot itself. Because if we did that, we'd have to make it, it would be, like a 400 quid robot. And you've already got all that stuff in your phone. So it made sense to use that both from a cost point of view and from a sustainability point of view. Because taking all of that exotic, high embodied resources, electronics, and sticking them in basically a toy seems a bit of a waste. So using your phone, putting it in the robot and making it use the AI, actually, that's what's in the GIF I was showing you before, wasn't it? In this GIF. But also, as well as that one, it came with this, there you go, that's the AI working. It also came with this unicorn and with this T-bot. So again, people effectively, they get the novelty of 3 different toys, but most of the resource footprint of just one. But then the idea is that they reuse the electronics and make their own things. And we've published loads of things, web projects you can do, like household waste and stuff, to make different kinds of robots and toys, and can be controlled with your phone. But also other people have done that. So this is on Twitter who did a work that where we did kind of remote telepresence stuff with the robots, and then he was in the workshop, and then he tweeted this a few weeks later. Really printed one with tracks and put it on Thingiverse, so anyone who has the kit can download that and make that robot. But I've also published a load of different ones for people to 3D print out of PLA. And then these ones down here were this like blimp project that was done by Chevrolet, I can't say it, some French designers, and in a kind of church somewhere in France, which was super cool. And then one thing that someone sent me that I was really happy to see was this guy. He had this like tank thing that was made by this company called Brookstone that used to have shops in airports in the US. And the company went out of business, and then the app disappeared from App Store, and so he couldn't. The tank became useless, and so he took a SmartyBot and he the circuit board inside, and again we deliberately designed it so that you could hack it into any kind of toy that ran on AA batteries basically, and he got it working again and gave it to his grandson basically as a toy. So that was really nice, because again that's something that otherwise they would have bought something totally new toy, and the SmartyBot, because we designed it to be really, really adaptable, they were able to use to kind of bring a toy back from the dead. Here it is running. It's pretty sweet, actually. And it was just super cool that he just sent me this stuff. It was like really lovely thing to see. So I hope there's loads of this kind of stuff going on that people are doing with SmartyBots I don't know about. But ultimately, I've got no idea. And I guess that's sort of the point I was making before about you don't really know whether you're helping, because whether you're helping relies a lot on users behaving in certain ways that you don't know anything about, and there are limited extents to which you're able to influence. So I didn't do an LCA for the SmartyBot, and the reason I didn't do it, like, this is the bill of materials just for the circuit boards, and it's, at least from me in my position, making a few thousand of them at a time, there's no way I would be able to get the information out of the suppliers of all of these components, what the actual embodied carbon of each of those components is, in order to work out the LCA. And even if I could get the information out of them, say I was making, maybe if I was making like hundreds of thousands of them at a time, they'd say, yeah, okay, we'll do it. We'll find out, we'll work it out. But I don't really have a way of telling whether they're lying about that or not. I haven't got a way of auditing that. So for kind of complicated products, particularly the kind of products like Internet of Things that me and Alex work on quite a lot, it's really, really, really hard to actually do an accurate LCA. You can kind of weigh the circuit board and try and make some assumptions about what components are on there and the kind of aggregate CO2 or embodied carbon of electronic components generally. But, you know, you might have a circuit board that was full of really, really expensive processors that almost certainly have a much, much higher carbon footprint than loads of like passive resistors, but, you know, but weigh the same amount. And so actually doing an accurate LCA for it's really hard. The closest thing I've seen of a good LCA, accurate LCA for a kind of complicated electronic thing was Dell did one for one of their laptops, and you know it runs to about 60 pages, but you know I think they did. I guess you know, not just it runs to 60 pages, like it seems to have been done by credible academics, and they seem to have followed a kind of a rigorous methodology. But it's interesting to see, you know, kind of how that pie chart, I guess, how it splits the stuff that's, you know, the stuff that's important, I guess. So like the, if you look at it, the mechanical, which is like the casing and everything else that holds it together, it's only 12%. So kind of, you know, again, trying to eliminate plastic from that laptop, you know, you're probably not going to do much. And actually, I think it's got a metal casing anyway. And actually, probably if it had a plastic casing, that would be a lot lower. But it's kind of like it's the PCB and the flash memory that where most of the embodied carbon is. But I mean, in a way, you don't have to do that, and you can still sound great because you can make the rules of thumb look really shiny. So this is a kind of ad from Apple. In my opinion, everything on this is a kind of arbitrary rule of thumb that probably correlates in no way whatsoever to embodied carbon, or correlates very, very weakly. So yeah, we're still at the point where this is kind of the currency of communication about this stuff. And to be fair, I think Apple are probably doing quite well, and probably better than most companies or many companies. But you know, it's still like this is the level of the discourse, I suppose. You know, most people seem, even people that are quite engaged, seem totally happy with the rules of thumb and not demanding to see quantitative analysis about actual embodied carbon in the products that they're buying. So I guess I've sort of alluded to them so far, but just to kind of summarize what I think the challenges with using life cycle assessment or analysis in design work are. One, you know, you can make life easier by using prepackaged tools, but they're expensive to use. You have to pay like big subscriptions. If you do it yourself, then you have to dig through quite a lot of academic papers to find your kind of source embodied carbon estimates for different materials. And a lot of them aren't open access, and so you have to pay for access. Even if you've got that data about kind of aggregate materials, you're still probably not going to be able to find actual data about your components that aren't, you know, just steel or concrete or plastic. So like all of those electronic components I was talking about, for example, but lots of other components as well that combine multiple materials and potentially processes that you don't know anything about how much energy they used or where the energy came from. I guess that's the other thing. I think processes that involve a lot of energy, obviously the carbon associated with that energy use is really, really dependent on how that energy was generated. And that in itself is also extremely hard to work out. If you do get information from your suppliers, you've got no way of validating whether it's true. and you'll need to make assumptions about the people that are using your product that you've got no way to test and may or may not be realistic, because the whole point is you're trying to model the whole life cycle of the product, so not just the resources associated with making it, but also in use and disposal, and you're almost certainly trying to compare that to a counterfactual. So there's a kind of a whole stack of assumptions that need to be built up there. Obviously in these three scenarios, so there are ways of kind of tracking carbon, I guess, and tracking carbon through supply chains. And there are people that are working on that, I suppose. So S&P, SAP are launching, they're doing it. They're trying to build a whole carbon accounting system. And obviously for these kind of accountancy firms and consultancies, this is a big opportunity because, if you actually want to work this out, the only way really is to have a parallel, independently audited accounting system for carbon that runs completely in parallel with the accounting system we already have for money. And that way you can say, well, this is the price of the thing, and this is the carbon price of the thing. And whether carbon's rationed or whether you're trying to reduce your carbon emissions voluntarily, you still need to know what the carbon price is. And the only way of actually knowing it is by having this accounting system that runs all the way through everything, in the same way that we have an accounting system for money that runs all the way through the whole length of supply chains. So it's definitely a big opportunity for accountancy firms and consultancy firms. And then there's even people working on it, the blockchain, I guess, that Provenance, a kind of London startup, working on using the blockchain to kind of track resource impacts of products through their life, through their supply chain. In my view, we shouldn't do this. I think building this whole parallel accountancy system isn't the answer, because actually the problem is relatively simple. It's mainly caused by digging fossil fuels out of the ground and burning them. These are some toy engines that I thought I'd illustrate that with. But yeah, these are the kind of processes that lead to carbon emissions that lead to climate change. And if we think about the supply chain that's created a smarty block, right? It's really, really complicated. It's almost unfathomably complicated. I mean, it took Dell 65 pages of, and like several people with PhDs working on it for like a year to work it out just for one laptop, and they probably didn't do that great a job of it. I'm sure they did do a really good job, but I'm sure they still had to make assumptions. I'm sure there's loads of stuff in there that they weren't sure about, because there isn't this parallel accounting system yet. So we can try and do that, I guess, or we can just say, well, what's actually quite simple is within this incredibly complicated supply chain for everything, there are some inputs that are relatively simple, which are fossil fuels, and there's and those lead to output, which is CO2. Obviously, that's a bit of a simplification, and there's a whole load of stuff to do with land use and things that we need to deal with that aren't covered by this. But in terms of products, this is actually most of the problem, and so we should probably be focusing on that in our intervention, and not be trying to solve this at the level of design decisions, I suppose, because without that accounting system, we can't make those design decisions with any confidence anyway. So there are 45,500 companies listed on stock exchanges globally. There are probably about 125 million companies in the world. So if you actually wanted to account whole supply chain for everything, you'd need at least most of those signed up, right? Definitely the listed ones, so at least 45,000, but probably a big chunk of that 125 million as well, right? So that's a hell of a lot of actors that need to be all signed up in a hell of a lot of different jurisdictions. They'll all need to be signed up for our accounting system and audited and everything. So it is a lot of work. But 100 companies are responsible for 70% of CO2 and methane emissions since 1998, because they're the companies that are mainly extracting the fossil fuels. So if we deal with this problem at that point, then it becomes a way easier problem to solve. So yeah, you know, we've got 125 million companies in these really complicated supply chains. We've only got 100 companies actually putting all the inputs in. So practically, that's a much better place to try and solve this problem than by doing design and trying to make low carbon design decisions, which is why I love the carbon tax. And ultimately, I think that's what we should really be focusing on, I guess, just trying to get an internationally applied carbon tax at source. You know, so anyone that digs fossil fuels out of the ground has to pay the carbon tax at the point where they dig the fossil fuels out of the ground. And then everything else is just business as usual. People go on trying to make things as cheap as possible, which is what most people are doing most of the time. And they also magically, everyone becomes a sustainable designer, designing things that have a lower carbon footprint. And if we don't even need it to be that bit high, actually, certainly not initially. Like the volatility we've seen in fossil fuel prices over the last 6 months is way higher than any price increase you'd actually need to, if you had a carbon tax, to actually drive meaningful change. The important thing is you just need to know that it's going to go up by a small amount every year. And so people, when they're making investment decisions about what their factory is going to look like in 15 years' time, can say, well, okay, I know that the price of fossil fuels is going to be at least this at this point, and therefore a whole load of things that currently don't make financial sense make financial sense. And everyone starts doing all kinds of amazing low carbon activities all the time because they're just doing what they were trying to do before, which was you know, try and make it cheaper and ultimately, yeah, make more money for, you know, because that is really what most people in business are trying to do most of the time. And that, you know, that doesn't need to destroy the planet. It's only destroying the planet because we're not pricing the externalities of burning fossil fuels correctly. The reason that I think the peril, I suppose. So I think we need to be like relentlessly focused on this, on messaging this. And I worry that by claiming to be able to do low carbon design with any confidence, particularly based on suspicious rules of thumb, I worry that we actually muddy that message and make it less likely that this is going to happen. And the reason I say that is there's this kind of quite interesting polling that YouGov did year before last. Kind of people were very like concerned about climate change, and you know, the majority of people are concerned about climate change and think we should do something about it. But the actual changes that people think, you know, they need to make are almost all things that have almost no impact or very marginal impact, like recycling. And you know, very few people kind of are keen to make the changes that are actually going to have a big impact, like paying more for fossil fuels or eating less meat. And I think that's yeah, I think that's a bit of a problem. And I wonder whether we as people purporting to do sustainable design might be contributing to that problem. So that's what I worry about, I guess. And I sort of, that was the question I wanted to leave you with. But thank you for listening. And yeah, sorry, that was super polemical.
That's how we like it, Ross. Don't worry. Thank you so much for this. And I've also kind of posted your breakdown of the talk and the blog post that you linked to, just in case, because we did miss tiny bits in the dropping on and off of connectivity. Questions from residents. I'm going to guess that you has a question.
I don't know. I don't really have question because the internet is not very smooth. So I couldn't completely understand the whole talk. I think I would watch the talk again later if there's a video online. But I have a question about this robot, this kids robot, the design, because I'm also is currently doing the similar things for the kids playing with technology or this kind of thing. I don't know how much it's connected to the environment, this issue when you design the whole like electrics or the whole you use cardboard, this kind of material. How you start and what's the design process once you design something for the children, and then you also need to connect to environment issue to try to reduce this kind of components.
Yeah, I mean, I guess everything I'm designing, I'm doing my best to try and reduce the carbon emissions relative to a notional counterfactual. I guess the point is, I don't have confidence. I don't have a lot of confidence that I'm actually doing that. But I am doing my best, and ultimately the way I'm doing it is, as I said, I have those rules of thumb about trying to design things that mitigate emissions elsewhere, trying to design things that last a long time, that are reusable, that allow people to kind of experience the novelty of new things without using a lot of resources, by making them in two parts, I guess. And so you have the part that has a lot of resources embodied in it, is reusable and lasts a long time, and then it works with other parts that are much more ephemeral, but embody much lower resources and are much easier to become part of a circular economy. But as I said, that it's all guesswork, I guess. And what I'm not confident about it. I'm not confident to say that I'm definitely helping or that other people should be doing the same thing. Ultimately what I think is that we need a carbon tax, and that in a way, most other things are just a distraction from that.
Yeah, thank you. Thank you for answering. Yeah.
Amanda, any thoughts?
Yeah, I had a question because during the presentation, particularly about the toys as well, I had this thought, not that I like this as a solution, but that if we follow this logic, then actually the most sustainable toys would be entirely digital.
Yeah, I mean, obviously there's a whole load of problems with that, right?
No, right,
So,
exactly. But if we're talking,
I guess that's what my point is. Making them more digital is helpful, I suppose. So I guess, yeah, using the phone as part of the toy rather than embedding what's in the phone in the toy. I think that is a good, of all the things that I've kind of said that I'm not sure about, I feel like I'm relatively confident about that, right? Because the phone, like the electronics that make that happen have got such a high embodied resource footprint that that's almost certain to be a useful thing, I suppose. And yeah, I think that is a good way of making things that are kind of a bit digital, I guess, but still have a physical footprint. I think that's the point. It's like, make the thing where the physical footprint it has as lower a resource footprint as possible, and then as much of the experience that needs to be delivered by something that has a high resource footprint is delivered digitally. I guess, interacting with the robot with the phone in it, or even interacting with the robot when you're driving it from the phone, is still quite a different experience from like just playing with an app.
No, definitely. And that's not a solution that I like. I was just like, that was my next train of thought after suggesting that, yeah, no, but it totally makes sense that to not duplicate the electronics, basically.
Yeah, I think also that, quite often you do see things, physical products, where you're like, that could just be an app. And like, I feel like if it can be an app, it's good that it can be an app, right? And in a way, it's great that there are these like incredibly multi-purpose computers that everyone's got in their pocket that are hugely powerful, right? That have accelerometers in and cameras and whatever, and you can repurpose for almost any use you want. That's an incredible opportunity. And actually it has reduced the resource use, we used to carry all kinds of different bits of electronics around with us that we don't anymore because it's all in our phone. And so, I think that is broadly a positive development. And I also think the fact that phones, like the life cycle of phones, is getting longer and longer is also, I think, quite a positive development.
Can I get you to reflect, Ross, on obviously you gave this talk last year and you've been interested in this topic for a little while, and you've been interested in this approach for a little while. Anybody that you can point to that is doing this well in terms of addressing systemic governmental policy making type shifts, and also engaging with the design community and engaging with creative communities who are at the, let's say, inventor stage of these ideas, whether that's different governments or different bodies or governmental bodies, or anybody who, you've seen in the last few years and you've gone, this is a step in the right direction?
Look, I guess, as I've said, my view is it's the campaigning at an international level that is the most impactful, right? And obviously there's a lot of amazing work that's been done in that area, and continues to be. And you know who we're talking about. I don't need to emphasize, I suppose. But I guess, again, this is really political, right? To me, my frustration about the campaigning, even the campaigning on the international level, is it isn't focused enough on the practicalities of actually putting this in place. I feel like there's too much of a focus on trying to get rid of capitalism. And it's like, we may want to do that, right? That might be the right thing to do, but we don't have time. Like, we've been trying to get rid of capitalism since the 1840s, and we're nowhere near starting. If we're going to wait that long to fix the problem with the climate, then we're completely stuffed. So we need to say, fixing this problem while leaving capitalism intact, some people view as a missed opportunity. But my view is, let's just fix it as quickly as possible using the economic structures we have. And then, and we can, at our leisure, try and get rid of capitalism if that's what we want to do. But I guess my frustration with a lot of the campaigning in the area is that it's it isn't enough. It focused enough on just like, we just need to build the price of the damage that's done by burning fossil fuels into fossil fuels. And it's like, that is, that's a relatively simple thing. That's what most of the climate scientists think we should do. But somehow it just becomes really, really complicated when that enters politics. And I think that's quite unhelpful. But again, I guess what I'm trying to say is, I also think, claiming to be able to solve these problems with design might be part of what's making it seem complicated.
Thank you, Ross. Such a great way to finish our talk structure for this whole couple of weeks. I will be in touch with you. I'll see what the quality of this recording is. I may want to, in fact, share last year's.
Yeah, I feel like I didn't change it very much.
No, which is fine. But just for quality, yeah. Thank you so much for taking the time to speak to us, and for everyone, thank you for joining. I'll stop the recording now.